All right, so let's go into this. This is 1.05. Remember on the last unit, we found the midpoint and the distance on a number line. Now we're going to find the midpoint and distance on a coordinate plane. It essentially, for midpoint, is the same thing. For distance, it will get a little more different, so just bear with me. So with midpoint, it's the same thing. So a point on the segment equidistant from both endpoints. So it's the same distance here as it is from here. Okay, when you find a midpoint on the coordinate plane, okay, I already wrote my points. There is a formula you can use, and that's what I have highlighted in orange right here. Okay, midpoint is the x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. Okay, so we're going to label our points x1 and y1, and then x2 and y2. Okay, so the most important part here, right, like being able to be successful with finding midpoint on a coordinate plane is just making sure you're putting the right x's and y's in the right part. Okay, I'm going to give you this formula on tests and quizzes, okay? But as long as you can just plug this in the right way, you will be successful, okay? So if I'm looking for the midpoint between this line, okay, I have x1, which is 7, okay? So I'm going to put in 7 plus x2, which is 2. So I plus 2 all over 2, comma, okay, y1, which is 5 plus y2, which is negative 4, all over 2. Okay, so the reason why this comma is here is because I want my answer for midpoint on a coordinate plane needs to be in a coordinate. Okay, it needs to be in a coordinate always. So when I'm finding midpoint on a coordinate plane, my answer needs to be in a coordinate. So 7 plus 2 is 9 divided by 2, comma, 5 plus negative 4, which gets us 1 half, and you can leave it like that. Okay, so how to be successful with finding midpoint on a coordinate plane is really just taking this formula right here and you making sure you just plug it in the right way. Okay. All right. So what are your x1 and y1? It's the coordinates of your first points. First endpoint. Let's put endpoint. Okay. X2 and y2 are your coordinates of your second set of endpoints. Okay, so I want you to try this next one. Remember the midpoint formula. X1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. Okay, it's the same formula we used to find midpoint on a number line, but now we're just doing it twice because we have two sets of numbers. So remember, we have x1 and y1 and x2 and y2. All right, finding endpoint on a coordinate plane. Okay, so this is when it gives you the midpoint. Okay, we know it gives us the midpoint because it says the midpoint of segment CD is negative 2, 1. The endpoint is C, negative 5, 7. What are the coordinates of the other endpoint? Okay, so if the midpoint is right here, Where do you think, what quadrant do you think our point D will be at? Okay, if you were thinking quadrant 4, you are correct. Okay, so we're kind of guessing that it's going to be in this quadrant somewhere. It's going to be in this quadrant somewhere. Okay. All right, so how you solve this, and I already have it highlighted, okay? You are going to take your midpoint, and that's what it's going to be set equal to, okay? So right here we have our midpoint, and it's set equal because that is our midpoint. So up here we have the midpoint formula, okay, where we get coordinates. So because we already have our midpoint, that's going to be on one side of the equation, okay? We then plug in what we know. And right now we know that C is our X1 and our Y1. And I kind of like to label the midpoint as XM and YM. So you might see that sometimes from me. Okay. So you're going to use the formula as normal. Okay. So remember the formula is midpoint X1 plus X2 divided by 2. Y1 plus Y2 divided by 2. But we don't have a Y2, so those are going to stay blank. But we have an X1, which is -5, so they did plug that in. Okay, so we took that X1 and we plugged in -5. We don't have an X2, so we don't plug that in. We have an X1, which is 7, and we don't have a Y2. So we plugged in the same way we would, but we're leaving Y2 blank because that's what we're trying to find. We plugged in our XM and our YM, which is -2, 1, on the left side of the equation. All right, and this is where there's two ways we can solve this, okay? So this is why I highlighted blue. The X is blue and the Y is blue. So I'm going to take this -2 because that is my XM, okay? That's my X coordinate of my midpoint. -2 is the X coordinate of my midpoint. And I'm going to set that equal to my formula, the first half of the formula for X's. So the average of the X's. So -5 plus X2, because we don't know that, divided by 2. Okay. And we are going to set the green highlighted because those are the average of the Y's. Okay. Equal to each other. So we have 1 equals 7 plus Y2 divided by 2. All right, and now you just solve for X. So I'm solving for X2 and I'm solving for Y2. These are two separate equations. Okay, two separate equations. So in order to get X by itself, I need to multiply by 2. So I get -2 times 2, which gets us -4. -5 plus X2. All right, and I need to get X2 by itself, so I add 5. All right, so X2 is finally by itself, and -4 plus 5, which gets us a +1. So our X coordinate, our X2 is 1. Okay, so we're not done. We need to find the Y coordinate. We're going to multiply by 2. So 1 times 2 is 2. We have 7 plus Y2 left. And then I'm going to subtract 7. Okay, so Y2 is -5. Okay, so in order to actually plot that, we're going to start at the origin. We're going to go 1 to the right because our X2 is 1. And our Y2 is -5. So our point D is at point 1, -5. So that's, we're going to go 1 to the right, 1, 2, 3, 4, 5 down. Point D is there. Okay. Okay, another way you can find this, and you'll probably like this more, and I hope my math was correct with this. Okay, all right, you can count the slope. So you're going to count the slope from C to M, just like you would on the number line, counting from the end point to the midpoint and then repeating it again. Okay, so we're going to count the slope. So we're going to go rise. So we're going to go 1, 2, 3, 4, 5, 6. So I added 6 down, and then I added 1, 2, 3. So plus 3 here. And now I just repeat. So 1, 2, 3, 4, 5, 6, and then 1, 2, 3. And then it gets us to point D. Either way. So you can do it algebraically, which is a little messy, or you can do it graphically. So here was it graphically. And here was it algebraically. A little messy. Sorry. It's a lot of information. Okay. Either way works. Okay, so I want you to try this one. So the midpoint, M for midpoint, is at 3, 5. So here's the midpoint. One endpoint is at 0, 1. So A is here. So be careful. The midpoint is right here. Okay, so the other endpoint should be still in the first quadrant. Okay, so we're looking for the other endpoint. We're looking for endpoint B. So you can do it graphically or algebraically. All right, last thing we're going to talk about, distance on a coordinate plane. There is a distance formula you will use. Same thing like we did with the midpoint. You're going to label your coordinates, x1, y1, x2, y2. Okay, so let's talk about it. When we are looking for distance on a number or a number line, we can just count. When looking for a distance on a coordinate plane, it's a little bit harder to count because it's a diagonal line. But notice how in this little example right here, we have a dotted line that's creating a right triangle. Okay, so there are two ways to find distance on a coordinate plane. Okay, we can use the distance formula, or we can create our own triangle and use Pythagorean theorem, because the distance formula is actually derived from the Pythagorean theorem. So if we remember what the Pythagorean theorem is the Pythagorean theorem is a squared plus b squared equals c squared. Okay, so remember this part right here being a, b, c, right? Just the sides. Okay, so if we take what they have labeled here for a, for b, and try to use the Pythagorean theorem for that, you're going to get this. Okay, so a squared plus b squared equals c squared. All right, so a, they have it underneath as x2 minus x1 squared. Then we're going to add b, which b is labeled as y2 minus y1 squared. And then they have c squared. Okay, all right. But remember that distance is only c. So in order to get rid of this to the squared, we're going to take the square root, which now you have the distance formula, which is the square root of x squared minus x1, or x2 minus x1 squared plus y2 minus y1 squared. Okay, so that was just me showing you how the distance formula works and why we're able to use Pythagorean theorem as well. Okay, so you can use Pythagorean theorem, make your own triangle, or you can use the distance formula. Okay, so for this first, what is the distance between U, which is at -7, 5, and V, 4 and negative 3, round to the nearest tenth. Okay, so there's two ways we can do it. We can use the distance formula, which, by the way, either way, it's the same, okay? So we're going to label our x's and our y's. So we get x1, y1, x2, y2. Guys, this is so important to always label your x's and your y's because it's easier to actually sit here and plug in, okay? Because it gets tricky because look, they have x2 first. So just be mindful of that. So we have the square root of x2, okay? We have x2, which is 4, minus x1, which is negative 7, squared, plus, so I did squared and then add, and I'm going to do another parentheses, and do this in blue. I have my y2, which is negative 3, minus my y1. Ooh, not the color I wanted. y1, which is 5 squared. And usually if we have a calculator, you can plug this all in the calculator and it gives you your answer right away. But we do not have that luxury unless you have your own calculator. So let me go through this. Okay, so we got to solve everything in the parentheses first. So we have a 4 minus a negative 7. A 4 minus a negative 7. Okay, so we should get 11 squared plus a negative 3 minus a 5. So negative 3 minus a 5, we get negative 8 squared. All right, just like it was for distance on a number line, it's the same thing. Distance on a coordinate plane should always be positive. Always, always, always. Okay? Even if we have a negative here, like right here with this negative 8, we have a positive. But because we square it, it turns it positive. Okay, so 11 times 11 is 121. Negative 8 times the negative 8 is 64. Okay. 121 plus 64. I get a 185, I believe. 64. Yep. All right. So once it rounded to the nearest tenth, so that's the first decimal. So nearest tenth is the first decimal. So I'm going to take the square root. I don't know this off the top of my head. I got to do mathematics. Calculator. Take the square root. And we get 13.60147. But it wants it to the nearest tenth. So 13.6 is the distance. And it's going to be units. So what we just calculated was from U to V, okay? The second way to do it is using Pythagorean theorem, okay? So using Pythagorean theorem, notice how I drew these dotted lines. So what I'm going to do is actually count my dotted lines. The key is you have to make a right triangle with your points. Okay, so notice how when I was drawing my dotted lines, I drew my dotted line up until I became even with point V. And then I just took this point at the corner of my right triangle and met it with point V. I made a right triangle between my points. That's the key of being successful using Pythagorean theorem. Okay, so I need to figure out what the side lengths are. So 1, 2, 3, 4, 5, 6, 7, 8. So, remember, if we're using Pythagorean theorem, it's a squared plus b squared equals c squared. Okay, and I'm going to write b squared in red because that's what I'm going to use. Okay, and then highlight. Okay, so the unit for A, we have 8. So we're going to plug in 8. Okay, notice how we're getting the same numbers. Okay, getting the same numbers. Okay, for this one, we have, for the bottom half, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I'm going to plug in 11 squared. Again, notice how I'm getting the same numbers. Okay, and then we got c squared. Well, 8 times 8, 8 squared is 64. 11 times 11 is 121. C squared. 121 plus 64 is 185 equals c squared. In order to get, I need c alone. C alone is distance. C alone for the Pythagorean theorem. I have to take the square root to get rid of it. Take the square root of c squared to get c by itself. And again, c equals the square root of 185, which gets us 13.6 units. Okay, so either way gets you the same answers. I do not care which way you use. You can use the formula, but the thing is you have to make sure you actually label correctly and plug it into the formula correctly. You can use Pythagorean theorem, but your first step is to always make a right triangle. Okay, make a right triangle, count your units, and then plug it into the formula. Okay, so I want you to try this one. Remember, if you're using the distance formula, we have x1, y1, x2, y2, and your distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, remember, first you want to solve everything on the parentheses first and then square, then add, then take the square root. Okay, I'll write those notes down. So first you want to plug in the right coordinates, plug in coordinates. It's always good to double check too. Step 2 is subtract parentheses first. That's not how you spell parentheses. Whatever. 3, you want to then square. Subtract both parentheses, by the way. And then you want to square both parentheses. And then step 4 is add 2 numbers that you get. And then step 5 is then take the square root. If you're doing the Pythagorean theorem, you must graph points. Step 2 is to make a right triangle with your points. Count side, they're called legs, so count the legs of triangle. So you want to count how many units, and then plug legs into Pythagorean theorem formula, which is a squared plus b squared equals c squared. And then step 5, solve for c. Just c, okay? Not c squared, solve for c. So there's steps on how you do that for both. All right, examples are coming soon. Bye, guys.